Any questions about the second assignment? So assignment 2 is due on the 10th. Anybody have any questions on that one? We've covered material for problems 1 and 2 thus far. We'll get to 3 and 4 today, hopefully. Okay, so let's do a week from today. So please get started on that as soon as you can, so that we can have some discussion on that material. All right, so going back to what we've been discussing here, the translations from English to predicate logic. We had this example where we were dealing with predicate logic statements that just have one variable in them. So we have these predicates here. P of x is a pony, g of x eats grass, r of x runs fast, and the domain is the whole universe. And we want to write a statement equivalent to all ponies eat grass. What might help as an intermediate step would be to rewrite the statement, if it's a universal statement or if it includes some universal statement, write it as an if-then. Right, so this is equivalent to saying if it's a pony, then it eats grass. All ponies eat grass. Right? Again, we're not talking about anything other than ponies. We're not talking about cows or dogs or people or fish or whatever the case might be, okay? Or tables or asteroids. We're just talking about ponies. So if it's a pony, then it eats grass. So for all x, p of x implies g of x. No ponies eats grass. No ponies eat grass, equivalent to saying if it's a pony, then it doesn't eat grass. Or if it eats grass, then it's not a pony. Right? Again, when you say no ponies do something, that means all ponies don't do that thing. So again, it's a universally quantified statement. Not all. So not all. So saying no ponies eat grass, that's universally quantifying ponies as not doing something. When you say not all ponies, not all, that's different than no. Not all means some, or there exists. Negating, we'll talk more about that today. Negating a universally quantified statement is an existential statement. So not all ponies eat grass means there is a pony that doesn't eat grass. Right? You could say it this way. Here the negation is in the subject. Here it's in the predicate or the direct object. Some ponies don't eat grass. If a pony eats grass, then it runs fast. So here, for all x, pony x and grass eater x implies runs fast. Only fast ponies eat grass is this one. All right, so now we want to get on to the two variable type statements. So this is a nice set of examples here. So b of x is a bee, f of x is a flower, lxy is x likes y. Remember, if you're going to say all bees do something. I don't care what that something is. All bees do something. It starts out as for all x, b of x implies. If you want to say some bees do something, all bees do something, some bees do something, there exists b of x and whatever's going to happen after that. So all bees like, sorry, all bees. So we start out like that, all bees. For all x, b of x implies. What does it imply? They like some kind of flower. So there exists a y, that's a flower, and x likes it. This could also be written with this existential quantifier up here. It still works like that. This is clear from more like a computational point of view, but as far as like the following the structure of the sentence, this is the interpretation that's more clear. All bees, again, we're saying all bees. So all bees for all x, b of x implies. What does it imply? He likes all flowers. Likes all flowers. So for every y, if it's a flower, right, here's all flowers. All bees do something. What's that something? They like all flowers. So here's all flowers. For all y, flower y implies. What does it imply? It implies that bee likes it. So this is perhaps the most immediate way to interpret it. There's other ways to do it. You can take this universal quantifier, put it up front. It still works, in terms of the definition of quantification and predicate logic statements. And then using that exportation tautology, this was also from homework assignment number 1, problem number 3. A implies B implies C, like that, is equivalent to A and B implies C. So this statement here, B implies F implies L, can be rewritten B and F implies L. So for every X and every Y, if X is a bee and Y is a flower, then the bee likes it. So there's 3 different ways to write that one. Some bees, okay. Some bees like all flowers. There exists an X that's a bee, and, some bees. What is it about some bees? They like all flowers. So we had that construction in the previous example. Again, this quantifier can be moved up front. Some bees don't like flowers. Again, some bees. Right, some bees. What about some bees? They don't like flowers. Which flowers? All of them. Right? So for all y, fy implies the bee doesn't like it. So same as this one, except it's got a knot there. All right, let's take some more example. How about no bees like all flowers. No bees like all flowers. Can you say it by putting the no, not putting the negation in front? So again, no bees equivalent to no bees do something means all bees don't do that something. What is that something? No bees like all flowers. So all bees don't like all flowers. So don't like all flowers means what? All bees don't
Like some.
like all flowers. Right, which is equivalent to saying, again, take the negation and push it to the end. All bees what? So if you don't like all flowers means what?
Sunflowers?
Sunflowers are what? What about sunflowers? Yes, sunflower, not sunflowers. Sunflowers are what? Right? Not all flowers. Not all flowers is sunflowers. And what about sunflowers?
Are liked.
Don't like all flowers.
Don't like them? Okay.
Sunflower doesn't like, right? All bees dislike sunflower. Or maybe you could say this is sort of a plural form when you say all bees. Right? When you say all bees, so it kind of doesn't make sense this way. It doesn't say exactly the right thing. When you say all bees or when you say all people, right? What are you talking about? You're talking about the whole population of bees, or you're talking about mankind or people kind in general, right? But when you say every bee or every person, right? Now it's universal, but you're singling out the person, right? So every bee dislikes some flower, right? I mean, depending on the bee, maybe there's a flower he doesn't like. Is different than the other bees, right? This bee doesn't like roses. This bee doesn't like sunflowers. Okay, so how do we write that? Every bee. So every bee. How does it start out? We've said it a few times already. All bees, every bee. How does it start out? Come on, guys. I've been talking about it for a while now. Every bee. How does it start out?
Would be all bees.
Yeah, I mean, every bee is sort of a singular form of all bees. So how does it start out as a predicate logic statement? What would I write?
All X, B of X implies.
That's it. Same as it's been. For all x, b of x, whoops, b of x implies what? What about every b?
There exists a flower.
There exists. This what? Exists. What variable should I use? Can I say there exists x?
Y.
Y. Such that what? Y is what?
A flower.
A flower. And what about it? What about that flower?
Bee doesn't like it.
The bee doesn't like it, so L not X, Y. So no bees, like all flowers. It is a good idea to try to push the the negative towards the end. So no bees like all flowers. All bees don't like all flowers. But again, you're negating the quantifier. Don't like all. Don't like all. Push the negative towards the end. Dislike some. You don't want to negate the quantifier. Right? Once you negate it and you push the negative here, then it makes more sense. So every bee doesn't like some flower. Flowers, flower, singular, plural, both work here. So no bees like all flowers. All right. How about this? No bee dislikes all flowers. No bee dislikes all flowers. So equivalent to every bee what? So equivalent to every bee doesn't dislike all flowers. Every bee doesn't dislike all flowers. It's kind of awkward. Well, again, doesn't dislike all of them means, right? I don't dislike everything means I what? Don't dislike all. So we got that double negative there. Don't dislike all. Again, push the negative, out from in front of the quantifier. Right? If you dislike everything, if it's not true that you dislike everything, then what?
There's something you do like.
Something you do like, right? The all becomes exists. Negating the all becomes there exists. So equivalent to every bee likes some flower. Right, which was an earlier example. I think that was the first example. Every bee likes some kind of flower. Yeah, all bees like some kinds of flowers. Oh, my handwriting is so bad. It's getting worse as I get older. This thing is hard to write on too. It's very slippery. So it's every bee likes some kind of flower. So we did that one already, but let's do it again, right? Every bee. How does that start out? For all x, For all x, what? Every b.
B of x.
Mm-hmm. Connector
Implies.
implies what? Likes some flower.
There exists.
There exists what? What variable?
Y.
Such that what?
Is it the O? No.
Well, not every bee likes something. Every bee likes some flower. So what's y, first of all?
Fx.
A flower, or y, right? Fy, connector.
Y. And Lxy.
Perfect. All right. Okay, how about this? Change things up a little. Only bees like flowers. Only bees like flowers. Only bees like flowers. So just bees. Not you and me. Not hornets. Not who else? Not hummingbirds. But nobody. Just bees. Just bees. And when you say only bees like flower, you excluding everyone else. You're excluding everyone else from liking flowers. Say it as an if-then statement. That might help. If what?
If it likes flowers,
If it likes flowers. Flowers. Then what?
It's a bee.
It's a bee. If it likes flowers, then it's a bee. Which flower? Any flower. Right? If it likes a flower, then it's a bee. If X is a hummingbird and Y is a flower, it doesn't like it. Alright, so if it likes flowers, so that's what we're quantifying universally, then it's a bee. So how do you say it likes flowers? A flower liker. Right? We don't have a predicate for liking flowers. Right? We got three predicates here. Right? We got a bee predicate, we got a flower predicate, and we got a liking predicate. So we have to combine these two to make a flower liking predicate. So fx and lxy. So if it likes flowers. Okay. So how are we quantifying flowers? Oops. How are we quantifying flowers? Universally or existentially? If it likes flowers. Which flowers? Just roses?
All flowers.
All of them. What about those things that like it?
All of them.
All of them. So things that like flowers, the things and the flowers are universally quantified. So how do we start that out? But the things and the flowers are not the same object. They're in general different objects. Right, so we need universal quantification. So what do I do? I would actually need two quantifiers, right? For every x and for every y. Okay, if, so x is the it and y is the flower. So if it likes flowers. So how would I write that?
LXY implies BX.
Well, that's just if x likes y, not that it's a flower liker. Yeah, LXY, yes. If x likes y and y is what?
BX.
Not a b.
No, the flower.
The flower, right?
Oh.
And the flower,
Yeah,
what?
the flower implies the bee.
Okay.
Yeah, x is the b. Yeah. If x likes y and y is a flower, if x likes y and y is a flower, then x is a bee. Because only bees like flowers. So you could also say it in the contrapositive for every x. So if it ain't a bee, then it doesn't like flowers. So in this case, it's a little bit different. Right? So this is one way to say it, and you would translate it like that. This is another way to say it. It's the contrapositive, right? If it likes flowers, then it's a bee. Contrapositive, if it's not a bee, then it doesn't like flowers. But when you write it in the predicate logic way, it's a little bit different. If it's not a bee, that's for every x, right? If it's not a bee, for every x, for every x what? For all x, b not x. So if it's not a bee, then it doesn't like flowers. Which flowers? All of them. Flower y implies x doesn't like it. So if you write it like this in the contrapositive, it comes out a little bit differently. Okay. Let's see. Let's take another example using the only. Bees only like flowers. So they only like flowers. They don't like honey. They don't like other bees. They don't like their hive. They only like flowers. So write this as an if-then. Bees only like flowers. That's the only thing they like. Right? So we're necessarily talking about bees here. Necessarily, we're talking about bees. The bees, they only like flowers, not honey, not other bees, not their hive, not trees, just flowers. Write it as an if-then.
Would it be if a bee likes it, then it's a flower?
Great, yeah. Great. If a bee likes it, then not a flower. if a bee likes it, then it's not a flower. All right, so which bees? Some bees or any bee?
I thought it would be, then it is a flower.
Oh, sorry. If a bee likes it, oh, then it is a flower. Yeah, sorry. It is a flower. Okay. Which bees? Yeah, only bees like. No, bees only like flowers. Yeah, if it's a bee and he likes it, then it's a flower. So which bees? Some bees or all of them? Or any bee, to say it in a singular form. You know, just the bees in my backyard or any bee? Which ones are we talking about? All of them? Or just some of
It
them?
would be any bee, so
Any
we
bee,
would,
yeah, any bee.
And yeah.
And what about the things it likes? Some of the things it likes, or any of them?
Only any flowers, since that's
Right.
what
I mean, in the subject here. So in the subject, we're talking about a bee and stuff it likes. Some of the things it likes, or all the things it likes. Yeah, later then flower. You know, we'll address the fact that it's a flower at the end of the sentence. But in the subject, you know, the if in the hypothesis, if it's a bee, any bee, and the bee likes it, which it's, some it's or all it's, with some things it likes or all the things it likes, or anything that it likes,
all.
all of them. So all bees and all things it likes. So we're universally quantifying bees and the things they like. So similar.
So even though it's only specifying that the bee only likes all flowers, we're technically
Oh,
saying that it likes. Go ahead.
no, not that it likes all flowers. It only likes flowers. Not that there are some flowers it doesn't.
Okay, yeah.
Yeah.
Okay, sorry.
Yeah. Bees and things that it likes. Universally quantified in the hypothesis. Does that clarify or?
Yeah, that helps a lot.
Okay. So similar to this construction here. So we're talking about this is flowers. This subject is flowers and those who like them. Now the subject is, or the hypothesis is, bees and the things they like. So if X is a bee and Y is a thing that bee likes, then it's a flower. So what goes here?
FX.
Of a Y.
FY.
FY.
FY, yeah. All right. So if if a bee likes it, then it's a flower. You know, of course, you can say it in the contrapositive form. In the contrapositive form, it's if it's not a flower, then what?
The bee doesn't like it.
Yeah, no bee likes it. All right. So if it's not a flower, for every X, well, let's put a Y since we're usually doing it that way. For every Y, F not Y, if its Y is not a flower, then no bee likes it. Which bees? All bees. For every Y, if Y isn't a flower, then for every X that's a bee, that bee doesn't like it. So if you write it like this, it comes out like this. I mean, these are the same. They're equivalent to each other. You can move this quantifier over here, and then quantifiers can, universal quantifiers can be flipped around. And then you can use the exportation tautology. But, and, you know, we're not going to getting into that. All right, so please take a look at the homework, and you know, we'll do some more examples of those, you know, as questions arise.
Will you be emailing the grades for assignment one?
Yeah, I will. Yeah, I didn't have my email tool set up to email the class, so I have them done. I just need to email them to you. That's why I sent that test email. If you got that. All right, interpretations. So, given an abstract, predicate logic statement, I guess it's time to go. Predicate logic statement, an interpretation of that statement is consists of one, a choice of domain, and two, a choice of meanings for the predicates. Okay, and then a predicate logic statement, it could be true over one interpretation, we've seen this already, or false over another interpretation, right? I mean, in the homework assignment, right, we have this same predicate logic statement, we just switched up the domains. And over some domains it was true, some domains it was false. So now we're taking another step back in abstraction. So an abstract predicate logic statement may be true over or in one interpretation, and false in another. So, for example, take this. For every x, hx implies mx, and there exists x, hx, oops, let me parentheses there, implies for every x, mx. So here's an interpretation. We'll say the domain. So with these, it's often better to use like numerical or mathematical examples. It tends to be a little bit clearer. But you know, you can choose other things as well. So we'll say the domain is just the set of positive integers, like that. And we'll say h of x is even, and m of x is equal to x divided by 2 is an integer. Integer or whole number, something like that. So in this interpretation, okay, what is the truth value of this statement? Well, for every x, so for every positive integer, if x is even, then x over 2 is an integer. That's true, yeah? There exists x in the domain such that x is even. Well, that's true as well. So you have true and true. Implies, well, and how about this one? For every x in the domain, x over 2 is an integer. That's false, right? Because 3 over 2 is not an integer. 5 over 2, 1 over 2, any odd number over 2. So this becomes true implies false. So the statement altogether, the statement is false over this domain, or over this interpretation. I could make another interpretation in which this is true. And actually with implication statements, that's always easier because you can just make the hypothesis false. Okay, but we're out of time for today. So please get a start on assignment number 2 so we can have some good Q&A next time. And I'll email the homework to you right after class here, okay? All right, everybody, have a good day, and I'll see you on Wednesday. Email me with any questions or concerns.
Take care.